Hello everyone. Today we're looking at the topic of index laws and notation, also sometimes known as indices and powers. So on the left-hand side, I've got a starting value which has a base and an index, and then in the video we're actually going to cover these three rules over here and then look at a couple of examples associated to these kind of questions. So to start with, I've got 3 to the power of 4 on the left-hand side. Now, when we talk about indices or index, that refers to the power up here. This is what we call the index. If there are more than one, or if we've got multiple values with index values, we call those indices. For example, here, M and N are indices. And then we have this value at the bottom, the 3, which the index is attached to, which we call the base. And we're going to look at values today where we've got questions where we have the same base and different bases associated to different indices. So starting with the very first value over here, 3 to the power of 4. 3 to the power of 4 simply means 3 times by 3 times by 3 times by 3, 4 times. And it's just a shorthand way of putting these values into notation. For example, if I had 3 to the 20, I don't want to write down 3 20 times. I can do it, it's just easier to write it in this form. Now, if I was to multiply that by 3 to the power of 3, that's the same as multiplying by 3 cubed, which is 3 times by 3 times by 3. And actually what we can see here is in total, I've got 4 3's over here and 3 3's over here. So technically, I could actually call this 3 to the power of 7. I could also work this out if I wanted to. 3 times 3 times 3 times 3 is 81. 3 times 3 times 3 is 27. And if you multiply those values together, you get a value of 2,187. But again, if this was a non-calculator question, that's quite challenging. And really, all we need to understand here is that this has created 4 7's. Now, what we can see actually is that if I had 4 3's here and 3 3's here, I actually could have got that just by adding these indices, the 4 and the 3. And that is actually how the multiplication will work. So all you do is you add the two indices. So over here, if I've got a to the m times by a to the n, I can add those to give me a to the m plus n. Now that only works if the indices have the same base. If I had 3 to the 4 times by 5 squared, I can't make that 15 to the power of 6. I can't add the 4 and the 2 and then times those together. It's not the same. 3 to the 4 is 3 times 3 times 3 times 3. 3 cubed or 5 squared is 5 times by 5. 3 times 3 times 3 times 3. And we can see that's not the same. That's not 15 to the power of 6 means 15 multiplied by itself 6 times. So it's not equal to that. You can only use this rule if the bases are the same. So that is the rule of multiplication. Now we also have the rule of division. So let's take a look at that. If I tweak this question and I rewrite it as, instead of it being 3 to the 4 times by 3 cubed, I'm going to change this to 3, or let's say 2 to the power of 8 divided by 2 to the power of 5. Now, 2 to the 8, which already said, is 2 times 2 times 2 times 2, 8 times. So 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, 7, 8. And when you divide, you can actually write that as a fraction. So just for the purpose of this, I'm going to write this as a fraction divided by 2 times by 2 times by 2 times by 2 times by 2. So 2 to the 8 divided by 2 to the 5. Now again, we could work out these values if we wanted to make it easier for ourselves, and that would give us on the top 256 would be our numerator, and our denominator would be 32. And if you are comfortable with your 32 times table, you might see that the value here is equal to 8. But again, that's not easy mathematics. There's an easier way of doing this. And actually, when we're dividing, you can cancel out what you've got from the top and from the bottom. I've got a 2 here and a 2 here. I've got a 2 here and a 2 here. I've got a 2 here and a 2 here. I've got a 2 here and a 2 here. I've got a 2 here and a 2 here. Effectively, what I've done is I've divided top and bottom by 2 5 times, or divided top and bottom by 32. And what that leaves on the bottom is, if I'm dividing by myself, I simply end up with 1 on the bottom. And over here, I'm left with 2 to the power of 3, which is the same as 8. 2 times 2 is 4, times 2 again is equal to 8. But again, that's quite long-winded. We have to write that all out. There is a simpler way. And actually, again, if you look at the indices, 8 and 5 subtract to make 3. And that is the rule for division. When you are dividing indices with the same base, you simply subtract the power. So a to the m minus n. So we looked at multiplication and we've looked at division, and we've seen that when you multiply, you add, and when you divide, you subtract. So let's now look at one other scenario. This is what we call the power rule. Power rule, I'm going to show you, starts with something like this. If I've got 4 squared to the power of 3. Now, when you have something to the power of 3, it means you're multiplying it by itself 3 times. So this is the same as multiplying 4 squared times by 4 squared times by 4 squared. So if I multiply this by itself 3 times, when you're multiplying, you add the indices. So here, this is going to be 2 plus 2 plus 2, which gives us a value of 6. So here we have a value of 6. Now, is there an easier way of obtaining that from the values of 2 and 3? Yes, there is. What we've done is we've found our value of 2, we've worked out 3 portions of that. So we've simply multiplied the 2 by the 3. And this power rule is also sort of linked to multiplication then. So over here, where I've got a to the m and n, this becomes a to the power of m times by n, or if you want to write it without the multiplication, a to the m n, because when you don't have anything in between that, it means multiplication. So here are our 3 rules. And what we're going to look at now are just a few examples where we use these 3 rules to make it easier for ourselves. So I'm going to turn this over, look at our 2 examples, which we have over here. So what we can see here is at the top, 5d squared times b cubed, or 5d squared b cubed, times by 2d to the power of 11 b. Now, the first thing to notice here is there are different things going on. We've got numbers which don't have the same base. We've got the letter D, and we've got the letter B. And when we deal with index laws, we've already seen that only values with the same base can be used for these index laws. So we're going to look at each letter here separately. We're going to say D squared and D to the 11, they're one set of values. B cubed and B are going to be another value, or another set of values. And then the 5 and 2 are just our numbers. Now, they don't have the same base, but we can still multiply these together. So if we look at 5 times 2, that's just going to give us a value of 10. Very simply, 5 times 2. We're not using any index laws for that. We then have d squared times by d to the 11. Now, if you're multiplying powers, you are adding the indices. So this is going to be d to the power of 13. And then finally, we're looking at b cubed and b. Now, b cubed is b times by b times by b. And on this side, that is another single b. Now, we can see here I've got 3 b's here and 1 b here. That makes b to the power of 4. But when I'm adding the indices, I've got 3 here and I don't have a value over here. And this is very important. This is where a lot of people make mistakes. We have to first identify that when there is a letter which doesn't have an index on it, it just means the index is 1. So over here, we are going to add the 3 with the 1 to make 4. So our final answer here is very simply 10 d to the 13 e to the power of 4. And that's our first rule. That's our first question, just using the very first rule. Now the next question is a combination of the second and third rule. We have here a multiplication, so we have here a power being involved and a division being involved. So we'll be looking at these rules. So when we think about BIDMAS, the first thing we do is work with our powers, work with our indices. So we look at rule number 3 first. We're going to expand this. Now, from our example above, we saw there are 2 values here that don't have powers on them. When they don't have powers, the power is simply 1. 1 and 1. So now when we use our power rule, we're going to multiply the value over here, the index here with the index here. This is going to give us 7 to the power of 4. P to the power of 2 times 4 is 8. And Q, 1 times 4, is 4. And then the rest of the question just stays the same. We are simply just dividing this by 7 squared, p to the 5, and q to the 4. So when we divide this, we end up with 7 to the 4 divided by 7 squared. So via division, that is a subtraction, which means we're left with 7 to the power of 2. So that's using the 7s. We've then got p to the 8 divided by p to the 5, which is p cubed. And then we've got q to the 4 divided by q to the 4, which is just going to be q to the power of 0. Now that looks like our final answer, 7 squared, p cubed, and q to the 0. However, just something to note, which we will look at in a later video, but if you divide a value by itself, q to the 4 divided by q to the 4, that's the same as, for example, doing 100 divided by 100, or 20 divided by 20, or 8 divided by 8. And whenever you divide a value by itself, you actually get 1. So actually, something we haven't looked at, which isn't as important for today, but we can add in, is that a value to the power of 0 is always equal to 1. Now, if you leave it like this, it's okay for now, but it's just something to note for later, that our final answer should just simply be 7 squared and p cubed. If you remember the q for 0 for this video, it's not a problem, but we will look at that in a later video. So once again, we used our different rules here, but we did it step by step. We first used our power rule to expand this bracket, and then we used our division rule of subtraction. And just as that final step was, anything divided by itself, q to the 4 divided by q to the 4 is just going to be equal to 1. Anyway, I hope that's made sense. If it hasn't, please leave a comment below or message me directly. Thank you very much. Take care.